everyone, and thank you for joining in today. It's my pleasure to introduce Adam Schill Collberg to present Easy Jupyter Notebook Graph Visualization in 10 minutes. Over to you, Adam.
Thank you, Kostya. Sorry about the long talk title. Let me share my screen here and some of the slides. Have a look at those. So welcome everyone for some graph visualization in Jupyter Notebooks. My name is Adam, and I'll be hosting this talk. Unfortunately, my colleague Florentin is ill, so his voice is not quite with him today, so he'll not be joining the talk. Let's get started. So I'll briefly go through motivation of why we built what we have built, and then I'll show you what we have built on a kind of a high level, explain some of the features, and then we'll end with the demo as well. So let's start. So as I'm sure many of you are aware, we already have Neo4j Bloom for visualizing graphs. And it's a really amazing tool. It's very interactive, performant, and beautiful tool for visualizing Neo4j graph databases. But of course, it has some limitations. So for example, if you want to visualize your graphs in a Jupyter Notebook instead of in the Bloom kind of standalone application, then that's not really possible. You cannot embed Bloom in a Jupyter Notebook, which is unfortunate. And it's also the case that you may not have your graph data inside a Neo4j database yet. So it could, for example, be in a GDS, Graph Data Science projection, or it could have it in Snowflake tables, or even something like Pandas data frames in your sort of local machine's memory. So these are some things that Bloom cannot really address at the moment. So there are other ways we could do this then instead of using Bloom. For example, there's the nice open source library PyVis that is built exactly for this task. The problem with PyVis is, however, that it's kind of very slow. As you get into like the thousands of number of nodes, it becomes prohibitively slow basically to render the graph. So it's not a great option for that reason if you want to visualize at scale. There's also a matplotlib, which I'm sure many also know. The problem with this is that it kind of renders static images that you can look at, but you cannot really interact with it. You cannot zoom and move nodes around, so you cannot really go deep with your data in that way. And also, since it's built to do a great deal of things, it's kind of harder to use. It's not like it doesn't have a simple interface for just viewing graphs like these. So what did we do? Well, we built a new Python package for doing graph visualizations. It's called Neo4j Vis, and this is what I'll be talking about today. So this library is just like Bloom, built on top of the Neo4j visualization library, NVL. It's a JavaScript library. So that means, of course, that we have the same visuals, the same beautiful visuals, and the same performance as Bloom. We even have GPU accelerations through WebGL, which is very cool. So it's very fast. It also means that it's interactive like Bloom. We get that for free with this NVL library. And this library is open source. It also has a very permissive license. It's GPL v3. So you can use it for free in your apps and so on. The Python API that we have built is designed to be kind of very, very easy to get started with, to just get going. It's not like defined for like doing great deal of customization, although you can do that as well. It's really meant to get you started very quickly to see your data. And to this end, we also have some convenience constructors for different data sources that I also mentioned previously. So, for example, you can, with just one method call, you can load a graph from Neo4j Graph Data Science library, a projection that you may have there. Or if you have your graph represented by tables in Snowflake, there's also just a one method in our library for just pulling those tables and looking at your Snowflake graph this way as well. And it also handles Pandas data frames, and there are more things as well. And it's very easy to install. It's on PyPI like most other libraries, so just pip install it like anything else. And here to the left, we can see just a little example of Neo4j Vis rendering the famous Cora dataset. All right, so that was the brief summary of Neo4j. Now I want to show a demo instead. So let me switch to my IDE here. Here we go. All right, so now I hope you can see my cursor IDE. So I'm going to go through this fairly quickly since it's a lightning talk, but we'll be sharing the notebook afterwards so you can look through everything in detail and so on. My main purpose here is just to kind of go through the most important features kind of rather quickly to just expose you to them, and then you can just go deeper on your own after the talk if you're interested in learning more. So I'll just be loading some environment variables first because we have a connection to a Neo4j database with the GDS install that we're going to use. But before doing that, I also want to show the GQL loader that we have. So the workflow when using Neo4j is always that you first create a so-called visualization graph, which is something we're doing here, and then you use that visualization graph and render it basically, and that will give you the HTTP that can be rendered by the notebook. And here we're importing the GQL create from GQL create constructor that this library has. So this constructor quite simply allows you to give it just a string that is a GQL create query or a Cypher query that I'm sure many of you already know. So let's just actually run it and see what it looks like. So here we can see we get a graph with 3 nodes and 2 relationships, which is kind of what we expect as well. That's what we have in this create query. You can see that we can move them around and so on. You can drag them, and you can also zoom by scrolling, and we can also scroll by these buttons here to the top right. There's also a screenshot button as well that will let you save a PNG of the visualization. If we hover, we can also see that the contrast is a little bit off in this IDE. It works better in the browser, but you can see that there's also hover effect here. We can see the node properties, for example, of the nodes. We can see that this node was named Carol, and we can see that also here in the GQL create query. So this is, as you can see, very easy to do. You just give it this string to this constructor, and then you can just render it. And this particular constructor can be useful if, for example, you don't have a database, but you have a create query and you want to visualize that, or you want to create a database, but you want to visualize what you're creating before doing so. Then this is rather handy. But let's move on now to look at the actual database. So, of course, this library supports rendering graphs from Neo4j as well. So in this case, I'm just instantiating a driver, a Neo4j Python driver, to talk to the database and give some credentials here from my environment. And then I just give the driver to this from Neo4j method that we also import up here. And then we can just, and then that will create the visualization graph by pulling data from the database using the driver. And then we can render that. So let's see what it looks like. Yeah, so in this case, we have a kind of a movie data sets. We have person nodes that are like actors and directors, and then we have movie nodes as well, and we can hover over them to see some more information about it. And you can see by default we have the captions being the node labels and the relationship types being the captions on the relationships. And and you can further configure this. You can specify the exact query you want to run to actually get different nodes from the database. And you can specify a different row limit here to get fewer or more nodes in your visualization. But let's move on. So next I want to look at how we can use this library with GDS, the Graph Data Science library. So I'm going to instantiate the GDS client here. And then we're going to create a GDS projection that only includes person nodes and they're only and just relationship between these nodes if they are acted in the same movie. So we're going to have actors that acted in the same movie being connected by the co-acted relationship type. So let's see what that looks like. Yes, so let's actually, I'm also going to, before we look at it, I'm also going to run a few algorithms here to get us some things we can visualize. I'm going to compute page strength to give kind of a importance or centrality score to each of the nodes. And then I'm going to do a community detection as well using Leiden. And we can use that later to configure our visualizations, to add it, to give more dynamics to it. So I'm going to do that. But let's look at the graph, the GDS projection. So now I'm using the from GDS constructor instead here. I'm also importing it from Neo4j, as you can see. So let's have a look. All right, so we have a lot of nodes now. I think there are around 100 of them. So it's going to be, here you see Kevin Bacon is the name of this one. So it's basically a bunch of actors that have co-acted with each other. It's kind of what we expect. So now we can customize this visualization a little bit. So one thing we can do is to actually use, you see that these nodes, they have a name property. So this is Philip Seymour Hoffman, for example. So we can actually use this name property and set that to be the caption as well, because now they're all captioned to be person, which is not very helpful. So by doing that, we can loop through the nodes here, the visualization graph nodes. We can set the caption here and just get the node property name, and then we can render it again to see what that looks like. All right, so now we can zoom in a little bit here. We can see that the nodes, indeed, they have names on them. The captions are names, not the node labeled person anymore. So it gives us some more info here on the first glance. All right, another thing we can do now is to use the community detection we created with Leiden and color the nodes by their communities. And then we're going to call the color nodes method that we have here, and we're going to say use the property community. So let's do that, and it looks like this. Pretty cool. So we can see that there are a couple of colors here, different communities. You can see it looks like it kind of makes sense, right? That these blue nodes, they are kind of huddled together here. These purple nodes, they look kind of densely coupled as well. So that's what Leiden also detected, and we can see that it kind of visually makes sense here with the different colors. So that's nice. And lastly, I also wanted to show that we can use PageRank. So we computed this PageRank score before, right? With GDS, that kind of gives a score of importance to each node, or a centrality score. And so now we have this score on the nodes, and we can use that to also size the nodes. So there's this resize method on the visualization graph. That essentially means that we're going to ask the library to resize the nodes based on this score, this PageRank score we have computed. And then we can just render it again. So let's see what that looks like. All right, let's scroll down a little bit here. Whoop. All right, so we can see that there are differences now in size. We have this Tom Hanks node here that looks very big. So it looks like he's co-acted with a lot of different people. He's done a lot of movies. Keanu Reeves, famous from The Matrix and so on, also seem to have co-acted with a lot of people. So these are the kind of the most, according to the PageRank algorithm, the kind of the most important nodes in the graph. All right. So that's kind of what I wanted to show here. I just want to kind of expose the various functionality of this library. Let me switch back to the slides. And I will say thank you for listening. And if you have any questions, my colleague Florentin will probably have answered some of them already, but I'll also try to stick around in the chat a little bit longer. And these slides will be made available to you, so you'll have these links to the notebook, to the GitHub repo, and the documentation. And yeah, that's really it for me. Yeah, so again, thank you so much for listening.